Next is Erin Stukenholtz. She is a postdoc from Christina Davies' lab in Carleton.
Oh, okay. Oh, there. Green button? Yes. Wrong green button. Okay, thank you. Okay, so as many of us know, 3 bat species within Ontario had populations decimated due to white nose syndrome. And to help recover these populations, we are focusing on identifying, characterizing, and protecting critical habitats. And one way to identify these critical habitats is just by looking at the annual cycle of these bats. Looking at where they're hibernating, where are they going during the winter, and roosting for hibernation. Identifying their maternity sites, these locations where females will gather together to give birth and rear their young. And then their swarming sites, where they're going to potentially show their offspring, where to hibernate over the winter, but also opportunities for mating. And also looking at these foraging sites and other roosting locations during the swarming and maternity season. Now, to identify these locations and characterize them, it's been difficult because we have very limited information. A great example of this is the tricolored bat. This is a map where we can see that there's a fair amount of swarming information and hibernation information on locations, but what we're missing is maternity, foraging, and migration occurrences. So here in blue, we only really have 3 recorded, and there's only really 2 maternity sites recorded in Ontario. However, we've recently identified a maternity colony this last summer, 2023. And at this maternity colony, there was approximately 33 individuals in July, so the post-volant season, and we found it in a barn. To get us a better idea of how to identify and characterize roosting locations and critical habitat for these species, we are looking at the information center hypothesis, which posits that uninformed individuals will follow informed individuals to roosting and foraging locations. This is the understanding that they don't have to do trial and error. An individual does not have to go out and try to find these locations, having more energy expenditure. Instead, they're following individuals that have that information. And so that can give us an idea on key locations such as foraging and roosting locations. This will help increase the survival of the individual and potentially help the fitness of the parent. So the object of the study was to identify tricolored bat habitat needs and also find key locations, roosting locations and foraging locations of these individuals by looking at roost networks and foraging locations that groups are going to. How do we do this? So we went to the maternity site and we used a hoop trap to catch these bats. Hoop trap was created by Perez Torres down in Colombia. He used it for social bats in caves. And what it is, it's basically a hula hoop with a net on it. And we just put it up against the roof and we let the bats fall in, and we'll then pick them up and put them in individual bags. To follow their movements, we use a low-tech nano tag that has a 3.7 second burst rate. And we attached it to 9 female adults, and 4 juveniles, I believe 3 males and 1 female. We then track their movements using a mini MODIS station. Now, many of you may be more familiar with larger MODIS stations. These have 9 elemental Yagi antennas. They have a huge detection range, and they're great for coarse spatial movements, such as migration. And they're primarily used for birds. We use mini MODIS. So instead of the Yagi antennas, we had these Omni antennas. Omni antenna has very much a circular range, and the detection range is much smaller. Now, what influences the detection range could be the landscape, it could be machinery, it could be the location, and we also believe gremlins because as you can see, there's a fairly big difference in the detection ranges of these stations that we have set out. Dr. Lisa Alessandro is part of our team, and she's really looking at calibrating these stations and using them for fine spatial scale movements. So while we have quite the range in our detection ranges, it's still allowing us to get a little bit more finer spatial scale movements compared to the larger MODIS towers. This is a shout out to Toby, who's really helped us with these stations and really helped us with this project. Okay, so we put these stations in a grid around the maternity site, so we can see how they're moving around. So we have one station right outside the maternity site, and we can see when the bats are leaving that station, so we can get an idea of activity. And we can see here around 8:55 in the evening, a lot of the detections just drop off, and so a lot of the bats are leaving around the same time. We can also see when they're starting to come back to the maternity site on the far left of the graph. We can also see the percent of detections at each one of these locations. This was taken a half an hour before sunset and a half an hour after sunrise. And I excluded the maternity site. In this map, in the gray, you can see it's part of the town, a very small town, and on the other side is more of the forest. So our maternity site is just on the edge of the forest. And looking at our detection, our percent detection, we see that the bats are not going toward the forest. They're actually going into the town toward the river, which you can kind of see in the blue. It's a good size river. It doesn't quite seem like it, but it's a fairly good size river. So the bats are not going toward the forest, they're going toward the river and into the town. Now to look at group movements. As I talked about earlier, the detection range, it kind of has a fairly good size, so it's really hard to pinpoint exactly where they are on the landscape and if they're really moving together. And so to get an idea of group movements, we did simultaneous detections. So this is when more than one tower picked up a bat. So as we can see here, where the two tower detection ranges overlap, we know we have a better idea of where that bat is in the landscape. So with that, we can get an idea of when that bat was there and kind of have an idea of where they are. And we can also see when other bats were also there at a very similar time. So this is within 20-second window. And this is for two stations. This is only for a select number of our bats, but we can see with our simultaneous detection of two towers that they were kind of pretty close to each other in that landscape. Now this is for all of our towers, for all of our bats. So these are simultaneous detections, so two towers at once. And these are for bats around the same time. So we can see that across time that they were hitting very close to the same landscape, going in the same direction. And from there, we can make a network. We can see what bats are traveling together and where they're at the same time at the same location. And we could see that these are all of our bats, that they're traveling almost at the same time. So we can get an idea where they are and how often they're going. And these are most often our detections were at the river, at our river stations. And so these bats are primarily using the river for foraging. Now for manual tracking, getting an idea of our roosting locations. So this is our roost sites network, and our little baddie, those are our bats. The whites are the juveniles, and the black are the adults. In our center here, that is our maternity site, so that's our barn. In the light blue, those are buildings that the bats roosted at, and in the green are the trees. And what we can see here is that bats didn't primarily focus at the maternity site. They started moving around the landscape and roosting in different locations. The juveniles were more often at the maternity site than the adults were. So when we were checking out the maternity site, we saw the juveniles there. The adults were not recorded at the maternity site as often. Looking at characteristics, so they roosted in buildings and trees. So what we found is we collected characteristics such as roof type, if they were in buildings with tin or shingles, material, if the building was made out of wood or masonry, the complexity, if there was a lot of hiding places, it would have been high. So if there was a porch or gable, or if it was low, there wasn't very many hiding places. For tree species, we looked at the genus. We also looked at decay stage, if it was a healthy tree versus a tree that was dead and on the ground. And then the crown position, which is the relative stature within the forest stand. So if it was a very tall tree, it would be dominant, it would be getting a lot of sunlight versus a suppressed tree, which is usually a sapling. And what we find is that they're roosting everywhere. They're not really roosting in one particular tree species or in just buildings or in just trees. We're finding them in buildings that have tin roofs, buildings that have shingles, buildings made of wood, buildings with not a lot of hiding places. We found them in maple trees. We also found them in ash trees. We found them in healthy trees. We also found them in some dead trees. We found them in trees that were dominant and then also trees that were more suppressed in the forest stand. And so we can't really prioritize a certain roosting location or roosting habitat because it kind of looks like they're roosting almost everywhere. And so with our group movements, we can get an idea of their foraging locations. Where are they primarily foraging as a group? And from this, we can tell that they're primarily foraging closer to the water. From there, but we also need to understand that we didn't tag a whole lot. We were in July, and so the bats they were volant, the juveniles were volant, but we didn't really tag that many because they were still too small to put a transmitter on. We only tagged about 13 individuals. And so that's about 40% of the colony. So we're missing bats that aren't tagged that are moving in a group potentially. Another step that we would love to do, and that we're doing this summer, is to see who's taking these juveniles to the foraging locations and the swarming locations. How are they finding these novel locations that they have never been to? And so we're going to look at the mother guidance and colony member guidance hypothesis that suggests that mothers are taking them to the swarming sites, or other colony members are taking them to swarming sites or the foraging locations. And so we're going to be collecting DNA to get a better idea. We did find out that one adult and one juvenile did end up at a swarming site very close to our maternity site at the same time. So it kind of gets us excited to kind of look into that further this year. Like I said earlier, one type of roost should not be prioritized over the other. The maternity roost was kind of the center roost. It's where all the bats were, the juveniles were there more often than the adults, but it kind of looks like they're roosting everywhere. And when we did look at availability of these roosts, we didn't find a significant result. So they might be flexible in their roost switching. So this just further is our investigation into tricolored bat movements. And the map here, this is actually from MODIS. I'm sorry, it's so fast. They do not move this fast, I swear. This is their movements throughout the landscape with our mini MODIS stations. When you see them going off the map, they're actually going toward a swarming site. Dylan White, this is kind of an extension of Dylan White's work. He looked at roost sites of bats caught at swarming sites, tricolored bats caught at swarming sites and looking at their roosting location. And so we're, as a group, as a lab, we're trying to connect the maternity and the swarming site and getting an idea of their roost network and their foraging locations. With that, I would like to thank the Algonquin people. I want to acknowledge that my research was taken on unceded territory of the Algonquin Nation, and with their stewardship and them taking care of the land, I was able to conduct my research. I would also like to thank all the wonderful people that helped us out with this project. It was a fantastic project, and I'm very happy to be a part of it. With that, I'll take any questions. Oh.
Questions?
I just have an easy question. I may have missed it in there, but
okay.
like with all the different roosts that you found, like how far are they from each other?
That is a great question. So the farthest roost that we recorded was 800 meters away from the maternity site. The swarming site itself is about 9 kilometers away. So for roosting, they stay pretty close, but for the swarming site, they really went a distance.
Hi, I was wondering, for the tree roosting sites, did you look at minimum DBH of the trees and also species of the trees?
So yeah, we did look at DBH for the trees. We did try to stay within a boundary. I'm sorry, I can't remember what the minimum boundary was. But yes, we did look at DBH, and I'm sorry, I'm forgetting what the number was. I had it on my slide.
Any more questions? Oh.
Really cool stuff, Erin. Maybe
you.
I'll do 2 quick questions then.
Okay.
So first one is, when the bats left to the swarming site, did anybody ever come back to the maternity area, or is once they're gone, they're gone?
That is a great question, and I haven't looked at that yet.
Okay.
I've been so focused on the maternity season because we're trying to do the swarming stuff next, and there's a lot of data with Motus.
So that's my other question, is I love the mini Motus. This
Yes.
is, I love that kind of thing. You've got the variation in the detection radius for each tower individually, which is awesome. Can you just quickly, like, what was the actual methodology to determine that detection radius?
Okay, so yeah, that's Dr. Lisa Alessandro, and I wish she was here because she's a bird person.
Bird people are good people too.
Bird people are great people because, yeah, Lisa's amazing. So what she did was she took a test tag, which is a 1-second burst interval and a GPS, and she went around and went around the maternity site and all these different locations with it up on a giant painter's pole in a truck, which is a really funny sight to see going through town. And we got a lot of strange looks from the people of that small town. And so she took that and she recorded the distance that the tag was picked up, and then within 70% of the tags picked up, what was the detection. And so for each detection, each line of detection, 70% of those detections for that one station was the 70% detection range.
Very cool, thank you.
Yes. Yes, if you do Motus, make sure you look at calibration.
Thank you very much, Erin.
Thank
Let's
you.
give her a round of applause. And